Hey, good afternoon, everybody. It's Mark here at Rainmakers Customs. Yeah, we're final assembly of our 8-pill 2x8 base. So we figured we'd go ahead and get in here, get this thing started. Speaking of which, give me a second. I'm going to put my sign up on the door. If I've got anybody that walks up to us, they can actually see that we are recording and we are live right here on our YouTube channel. So, for those of you that's going to be tuning in or starting to tune in from Facebook, we've got, we're running a little bit behind, but we had a phone call that we were finishing up on. But anyways, down to the last of it. So, figured we'd get in here and, like I said, get some stuff rolling. So, today's been full of Quintus interruptus, as per normal, it seems like. So, try to get these all started here, and then we'll tighten them up. And we'll grab a different screw. See what we can't do here by getting that started. So there's always that one that wants to give you a little bit of a fit. There we go. So I went ahead and I pre-tinned and soldered my main power leads on. We did just hook up the AC with using the as far as on the ground side. The reason why is because this is actually just a case ground. So since the case itself is going to be physically bonded to the overall case, and then we've got our ground wire here. It's not really a necessity that we do that. See what we can't do here about getting some of this all lined up. And I'm actually using a little bit different type of screw than what most guys would. And I'll show you here as soon as we get this module here started. Hit the hole. But anyways, show you this here. You notice that the head, unlike a standard, let's grab one here out of the other drawer here. Anyways, get this thing to focus. All right, this is a standard pan head. This is what they call truss head. And as you can see, part of it has to do with the massive size difference. Now, granted, this is this is for number 6, and this is for number 8. In relationship to that, just so happens we've got a number 6 here as well. Again, you're going to see a large difference in the size, but I like using these just because of the fact that they do have a larger lip, so it's almost like a built-in washer. Makes for mounting stuff a little bit easier as far as on the overall. Leave that loose. So each one of these power supplies are actually going to be mounted down with dual screw, with 2 screws in it as far as into the back side of it. And then when we get ready to do the complete final off on this, what we'll do is we'll go back, we'll take a measurement and confirm our distance from hole to hole, and then there'll actually be a strap that I'll put across all of these modules, and that strap will actually just help us ensure that these can't move, to give a little more stability to it, especially when we go to ship this. So like I said, there'll be a strap across different things. But I also like to be a little different than everybody else too, so just a little warm in here, so I figured we'd kick that up. Alrighty. Anyways, so going along through here, this other screw in here, then we're going to figure out how we're going to get all this stuff worked down. We'll get some zip ties on it, make it nice and clean. Okay. Now we're going to go back, since we've got that one now mounted. We'll go back. We're going to tighten up all these by hand. That way you can feel how much pressure is actually against them. The screws I'm using are basically just enough to go through the main cabinet itself, as well as through the power supply. Essentially, it'll go approximately a 16th inch past the actual thickness of the threaded portion of this. So that way we know that we can't get into any of the main electronics. Generally, on most of the 30, 40s, and 50s, usually they're pretty good about their spacing as far as on your screw holes here as you go along, where you don't have to worry too much. But some of them, depending on the 30 amp switchers especially. Now these here are actually 40 amp modules that I'm using in this case here versus 30s, which is in a lot of builds. But the metal itself, because of where they do a push through on this, on the extrusion for the holes, you actually get a little more thread depth than just the thickness of the casing itself. So, like I said, I know that we're going to go on above and beyond into the main case so that we've got full strength on each one of those as it's held in place. And the reason why I'm choosing to use a handheld screwdriver versus my electric to do the final tweak on those as far as tighten them all down is to make sure that since these are all nice and tight, that we actually don't strip it out. But because of the height that they are, you're going to be able to see just a little bit of wiggle room in between these, which is fine. But we also want to make sure, like I said, we're actually going to be running a strap across here to go ahead and lock these all together and tie them. That way, again, during shipping, we don't have to worry about these getting damaged or possibly causing any other type of damage to the main unit itself. So, and we've already got our feet installed. I'll show you the back of it here before we lay it down. So we've got a nice symmetrical locations here across the bottom. We've also got same type of screws that we're using here as well for the capacitor, which is actually kind of unique because it's a lot of bang for the buck. It's actually a 56,000 microfarad capacitor that is crammed into a very small space, which is great for what we're doing here because of the fact that it doesn't take up a whole lot of room. So we're going to lay these cables here out of our way for right now. And what we're using here also is Teflon wire, is what has been used for the overall AC coming in. It's not an absolute necessity, but I've got more Teflon wire laying around as a general of thumb. So most of the time, I like using the Teflon. Plus, a lot better insulation factor as far as on the overall. And we're using what we call the summing of wires. And what that means is we are using the sum total length from one module to the other, even on the AC side, we're actually using all the same lengths. And what that's going to allow us to do is take our AC coming in and apply to each one of these modules simultaneously, and not be off a couple of nanoseconds here or that. We're actually going to have the same input going to each one of these. So I was looking for a connector a while ago because I thought I had one laid up here. So hopefully if that'll hold together just long enough, we'll go over here to the other side, get us a connector here out of the room so we can hook up our AC. We're going to say good afternoon to those of you that are watching. You should be able to comment while we're talking, I think. I've got the chat head actually active. That way, if you guys would like to, you're welcome to comment as we go along or ask questions. All right. Apparently, I don't have the size I'm looking for, so we're going to make what we need. Truth be told, would be actually better than what it would have been if we'd have had a factory butt splice for this. And we'll show you here in just a second how we're going to do that. So we're going to get our little bench top vise out. I'm not going to put a lot of pressure on that, but we're going to put just enough to hold it in place. Okay. We're going to get an idea how long we need that. And instead of using a regular hacksaw, I'm actually going to be using a jeweler's saw. The only reason why we're using a jeweler's saw on this is mainly because of the fact that I had to use my tubing cutter the other day out in the garage, but on something I was working for, and I don't want to go back out there. But I still want a nice clean cut. Actually, we're going to leave that on there. Make sure that's deburred here. Not going to be much of a burr. this one in. Okay. And I know you guys are probably wondering, okay, what's he up to next? What we're actually going to do next is I'm going to take a small drill and right in the middle of it, just try not to put any more pressure than is needed on that. We're going to drill a small hole, and the reason why is that way we can actually wick up solder up inside this connector, so not only will it be butt spliced together, it'll also be soldered. I know usually, guys, I sit there and do this stuff live on Facebook, but I thought for change we'd go ahead and switch over here to YouTube. See if we can't get some more subscribers. It's part of the reason why we're doing it this way. Okay. I know that's going to hold good right where it's at. Like I said, once we get the other wire in there, then we'll go back and hit that with a little bit of solder. We also need to make sure we've got that heat shrinked as well for safety. Also, we're going to put a double piece of heat shrink over top of it. And there again, that's going to be also for a little bit more safety as well. We've got standard 2-to-1 that we're using, and then I'm actually using a very heavy 3-to-1. It's actually going to be shrunk down over top of it, which actually has an adhesive seal on top of it. So that way, whenever we go to make the connection 100% complete, we know that it can't move. We know that even in a smooth environment such as it's going to be in, we're not going to have to worry too much about it. But here again, safety, safety, safety. I said it may be overkill, but still want to be as safe as we can on it. this put out of the way, and we'll go to the next piece. It always takes a bit whenever you're doing this too, as far as if you're wanting to try to get solder wick down into it, mainly because of the fact that you've got such a mass to actually heat up. And just because the hole covers up or closes up at the very beginning doesn't mean that it's full. It just means that the rest of the wire and whatever else is inside there hasn't exactly sucked it all in. So what I'm doing, and I know it's kind of hard to see, I've actually got it next to the hole. So that I'm heating it up next to it, and that way we can actually draw it down inside of it. Okay. So while we're waiting on that to cool, I'm going to go ahead and take this while we're not wasting time, waiting on that to cool down. We're going to take our wires off of that. I've already got these pre-made. Like I said, today's just been kind of a crazy day. Like I said, just a lot of interruptions. You know, and sometimes it's real difficult to get some of the basics done anymore, just because you've got to answer so many questions throughout the day. Okay. And yes, guys, this is fingernail polish that we're using. Reason why is because it acts a lot like Loctite. It doesn't hold as tight, but it holds just well enough to ensure that you don't have anything come loose, generally speaking. So usually I like to use that. Most of the time I'll just use this clear. You can pick it up pretty much anywhere. Uh, but just like anything else, even if you're using fingernail polish for a type of Loctite, buy the good stuff. Even the women will tell you. Let's bring that up a little bit more. Hopefully everybody had a great weekend. Overall, mine wasn't too bad. Still didn't get as much accomplished in here in the shop as I wanted to. Of course, yesterday I wasn't feeling the greatest, so very little got accomplished that should have been. And then today, since it's Monday, we have had umpteen bajillion phone calls and text messages and emails and all that other good stuff. Okay. We've got this all folded back. We're all starting to anyways. We're going to go ahead and put a couple of zip ties in place as we're going along. Here again, just to kind of clean it up, make it look sniffy and pretty. So I'm not sure if this is going to make it any easier or not, but we're going to try it anyways this way. And most everything that I think is hand built is like a piece of art. Just like a piece of art, even something as basic as your wiring, I think should look nice. Yeah, I took out a little bit of time today too, and I did some research online, and hopefully, for those of you that watch most of my live feeds that I do on Facebook, hopefully we're going to try once and for all to take care of some of the glitching with the videos. I went ahead and ordered a 150-foot cable for the computer to go in and hook into the internet server that I've got in the house. Hopefully that will take care of some of the glitches that we've been having. At least that's our intentions and our game plan anyways. Now, I've never ran one that long before as far as to tie into your wireless modem. So any of you guys that have had, if there's any kind of little glitches or anything like that that you've ran into, let me know. You know, because like I said, that's one of the things that we're going to try to do to hopefully make things a little bit better for you guys who enjoy watching videos. That's what we're hoping to alleviate, is some of these glitches that we've been having online. You know, it never ceases to amaze me, though, on something as simple as a project like this. How many zip ties does it take? Have you ever noticed that, guys? How many zip ties does it take to actually do a complete project? Oh, I love these guys. The hydraulic breakers, easy to use. You use them to turn the amps on and off. They serve as a circuit breaker as well. You know, it's an all-in-one. You got less cutting, less mess, less wiring in the long run, less things to go wrong. One of the greatest inventions, man. Okay. Now, the other thing too, a lot of people don't realize that anytime you're using something like this, any kind of a trip breaker or a um, yeah, or a regular circuit breaker, oftentimes it's best if you actually read on the side of these. And the reason why I point this out is because it actually helps in relationship to how these trip and when they trip. You know, not just with a short circuit. For example, like this one here, you know, you've got your line voltage that comes in from the top. You've got your load that comes in on the bottom. Okay. Well, what it is even though this is an AC breaker, because of the way that the current actually flows through this, um, these are set up whether you're dealing with a hydraulic breaker or whether you're dealing with a thermal. Um, it is at which side that the current or the heat dissipation on the inside actually works. You know, a short works a little different than the thermal dynamics, but it's also because of the thermal, as far as if you're drawing too much current through there and you're actually heating it up. Typically, there is a spring, some type of either a spring or a metal tab that's actually designed that once it hits a certain physical temperature, it actually springs just like a coil spring on a car or something like that in order to disconnect itself. So, you know, I just kind of wanted to point that out. And wow, it's almost 5 o'clock. But like I said, kind of wanted to show you guys a little bit about that as well. I know I've got a call coming in, but we'll have to get to them here in just a few minutes. But anyways, since we know that the load is going to go to the bottom, let's hook the load up first, and then we'll go to the top and hook up our AC coming in. Now also, let's move that camera up here a little bit. You guys can see more what I'm doing. All right. Now one of the other things that I wanted to point out is not only in the back, but also up here by the hydraulic breaker, we've actually installed our ferrites in order to go ahead and make it a little bit better so that if we do have any kind of AC noise come in, the ferrites are going to help reduce any kind of electrical noise that would come into the system as well off of the AC lines. Now once this is done and we start in on the other section of it, which is going to be on our DC side, granted there's already ferrites that are installed as far as to our main bus bar. We're going to be hooking up all of our current to, which goes across here. There also will be ferrites that are going to be installed here. There again, it's just to take out any kind of EMF that could possibly make its way through there. Granted, that doesn't mean that it's going to reduce and eliminate any and all noise, but it's just another fail-safe in order to go ahead and try to take care of every application or every aspect of what we're dealing with when we're doing the installation, and so that the customer has the best product when we get to that stage. All right. Again, this is another one of those that it's always best to maybe get them started, but use a physical screwdriver, do it by hand, tighten it up, because you don't want to over tighten and damage your breaker. Depending on what breaker that you buy, these run anywhere from $15 to $45, guys. So make sure that you pay real close attention when you go to put those together, so that you don't actually damage those. All right, now we need a couple of switches. I know some people don't do this, some people do. I try to set what they call the backstop nut, which is right here. I usually go ahead and unscrew that off of all the way down and bring it up a little bit. And all that does is it takes more of the thread itself out of the face of it and makes your switch look a little bit nicer on the front of the amplifiers. So, not a necessity. It's just something that I prefer to do myself. I feel too much clear coat on there, but we're going to take a small piece of sandpaper and clean that off. Okay. There. Now, the reason why we did that was so that when we go to put the LEDs in, we don't have to worry about the LEDs actually not getting a ground. than a lot of these that are clear. Just something different. And let's see. Now this guy's hooking this up to a traditional Cobra 2000. So I'm going to use red as his other indicator. So this amplifier is actually actually set up with a fully biased setup. So we're going to have one switch which is going to be for his standby. That way, whenever the amplifier itself is on, he can actually let it cool down a little bit in between keys or what have you, if he chooses to do so. That's what the standby switch is for. You know, it's just a personal preference. I prefer to put a standby on there myself. It's not actually necessary. You know, mainly because you've got your main switch that shuts everything on and off. But this way, if he chooses so, you can leave it on, let the fan run, keep things nice and cool. Well, you guys can kind of see, nice clean look. We utilized all 4 holes. We've got a regular breaker in here. Now for the rest of the wiring. Good times. But before we do that, I am going to go ahead and take a pause, guys. I'm going to stop this video and we'll come back to it here in just a short. I'm going to take care of a couple of calls that I missed a while ago. I know one of them in particular is kind of important, so we need to get that taken care of. And then we'll come back on our live feed, depending on where I'm at while I'm on the phone. We'll see what else we can't get done to this. So, folks, I hope you've enjoyed what little we've spent here time-wise on this. Like I said, we're going to go ahead and get this up and going and finished up and go from there. So, everybody, appreciate you watching. We'll talk to you soon. Maybe. Gotta love technology, guys. Okay, for whatever reason, YouTube does not want me to leave my page, I guess. So there we go.